In 1963, an astronomy student named Gail Smith, working at an observatory in the Netherlands, discovered something odd: a massive cloud of gas orbiting the Milky Way galaxy. Smith cloud contained enough gas to make the 2 million stars the size of our sun, and it was moving through the space at 7 lakh miles per hour. For the next 40 years, the cloud remained a curiosity, one of a growing number of so-called high-velocity clouds that circling the Milky Way. This is very interesting but not sensational. Then something changed. In mid-2000, radio astronomer J. Lockman and the colleagues took a closer look at the Smith cloud using the Green Bank Radio Telescope in West Virginia, and they were able to calculate the cloud's orbit. Smith clouds, its turnout, is a collision course with the Milky Way. 20 million years from now, give or take a few million years, it will crash into the Perseus arm of our galaxy. The impact will compress the clouds of gas in that spiral arm, that causing a brilliant burst of star formation. There is no real danger to the Milky Way. Smith cloud is minuscule compared to the gigantic spiral stars that makes up the backbone of our galaxy. But the coming collision has sharply increased the interest in Smith's cloud. Andrew Ford's Space Telescope Science Institute says we don't fully understand the Smith cloud's origin. There are two leading theories. One is that it was blown out of Milky Way, perhaps by a dust or supernova explosion. To investigate these theories, Fox and the colleagues recently peered into the cloud using the Hubble Space Telescope's Cosmic Origin Spectrograph. One of the elements they found was sulfur, absorbing ultraviolet light from the bright cores of 3 galaxies far beyond the cloud. By analyzing the amount of light the Smith cloud absorbed, the astronomers were able to measure the abundance of sulfur in the cloud. Fox says the abundance of sulfur in the Smith cloud is similar to the abundance of sulfur in the outer disk of our own Milky Way. That means we have a family relationship. He says the cloud appeared to have been ejected from within the Milky Way and is now falling back. It's basically falling apart. This means that not all of the material in the Smith cloud will survive to form the new star. But if it does survive, or some part of it does, it should produce an impressive burst of star formation.
Want to join us on our journey to the greatest mysteries and sensational discoveries? Then subscribe to Bright Keralite English and never miss any of our videos in the future. Remember to give our posters a thumbs up to show us that we keep you engaged with our content.